Okay, some basic concepts of chemistry.
Yeah.
Just see like what is that? I think it will be more of to refresh our memory and some concepts.
Yeah.
I didn't expect this would take this much time. Okay. All right. Okay. It opens as PDF. Okay.
Yeah.
So I think this will be slightly, maybe I should increase the. Okay, looks okay. Slightly I'm zooming in.
Okay.
Can you see that now?
Yeah, I can.
Okay. So the science of molecules and their transformations. It's a science not so much of the 100 elements, but of the infinite variety of molecules that may be built from them. Roald Hoffman. It's a motivational quote. All right. So it is a describing and understanding nature. We learned in the previous classes the diverse substances present in nature and changes in them in daily life. Curd formation from milk, formation of vinegar from sugarcane juice, on keeping for prolonged time, and rusting of iron. By the way, you've seen rusting of iron phenomenon in your house also, right?
Yeah.
Okay, for the sake of convenience, science is subdivided into various disciplines: chemistry, physics, biology, geology. Branch of science that studies the preparation, property, structure, and reactions of material substances. Okay, preparation, properties, structure, and reaction of material substances. It's called chemistry. Okay. After studying the unit, okay, there are a lot of points they have covered. Okay. So, characteristics of 3 states of matter and classifying the substances into elements, compounds, mixtures, scientific notations, determine significant figures, and we differentiate between precision and accuracy, and standard international base units, and convert physical quantity from one system of units to another, various laws of chemical combination, significance of atomic mass, average atomic mass, molecular mass, formula mass, then the terms mole and molar mass, then the mass percent of component. Okay, I think we should be able to quickly go through just to refresh your memory. I think so far. By the way, have you read this book Lessons fully earlier?
Actually, we don't really go through textbooks. We go through just the formula because we usually get questions based on problems. So they usually just give us the formula and they tell us to directly go to sums. So we haven't really used the NCERT textbook.
Okay. Okay. All right. So yeah, I think we will just use it to go over the logic in which they have developed the content. Okay, so that
Yeah.
the formulas also you will see it in the context of the concept. Okay,
Yeah.
so basically you get an idea of the concept, and then you kind of understand the formulas, and that way you'd be able to remember, recall, and also apply it to
Yeah.
different problems. But I think we will not go into the history. Okay, so it's like they've written as a story, but it's actually very interesting. I mean, if when we read through it, it's very interesting. But I think maybe in the interest of time, we may skip those historical informations. Okay, because I don't think any of historical related questions would come.
Yeah.
Correct?
Yeah.
Okay. Like for example, here they say chemistry developed mainly in the form of alchemy and electrochemistry during 1300 to 1600 CE. Now you not get such question, right? Like in which year alchemy and
No,
electrochemistry has developed? Like that kind of question won't come, right, in the chemistry.
no, it won't. It
Yeah,
won't.
yeah. So we'll just kind of skim over those historical information quickly. But we'll just focus on the concepts. Uh,
Hmm.
okay. And I think they're like describing the history of India and also Chinese, and in
Hmm.
ancient India, like what was it called? Rasayans,
Yeah.
Shastra, Rastantra, Raskriya, and Rasvidya. Rasvidya. Okay. Metallurgy, medicine, manufacture of cosmetics, glass, dyes, etc. Okay, and then some excavation, archaeological findings. Okay, that also showed us how does all like the construction work were carried in India a long time back,
Hmm.
uh, and how they did melted and forged various objects. Okay, so by looking at the archaeological materials, we understand
Yeah.
that how in the early years in India they were doing compounds, mixtures, and creating
Hmm.
the utensils. Okay, according to Rig Veda, okay, vast number of statements, ancient Vedic literature, okay. Agree with modern scientific findings, okay. Copper utensils, iron, been found in many archaeological sites, okay. So basically, this portion is for you to understand that in India, all through the archaeological excavations, we understand that the work of chemistry has long been happening in our country.
Yeah.
Uh, Rasarvanavam, what Rasarnavam appeared around 800 CE. Uh, discusses the uses of various furnaces, ovens, crucibles. Chakrapani discovered mercury sulfide. I think the discovery related could be a one mark question kind of thing.
Okay.
Credit uh, paintings fresh even
Hmm.
after ages achieved in ancient India, just composed in okay. Entirely from extracts of various plants, fruits, seeds, and barks, which are concentrated by boiling and then treated with various resins. Okay, we'll go to the next. Again, the historical information. What is
Hmm.
mentioned in the other Veda: turmeric, madder, sunflower, special references to perfumes and cosmetics. And since paper was known to India in 17th century, as an account of Chinese traveler I Sing, I to Sing. Okay, so process of fermentation, philosophical speculations. Okay, Kanda I said okay. So even Charaha Samhita, where old as Ayurvedic epic of India. Okay, Charaha Samhita,
Yeah.
Charaha Samhita, Basma of metals in the treatments of ailments. After the okay stagnation, Ayurveda continued to exist. Okay, it declined gradually. Okay, foreign products. Okay, because of the foreign products, modern science, the 19th century, European scientists came to India and modern chemistry started growing. Okay, so from the above discussion, we learned composition, structure, properties, and intersection of matter, which is of useful to our daily use, and basic constitution of matter, atoms and molecules, science of atoms and molecules, number of atoms and molecules in a given mass of matter, and have a quantitative relationship. how physical properties of matter can be quantitatively described using numerical values with suitable units. In fact, yeah, I think you may have some confusion on that molecules and moles and all, right?
Yeah.
Importance of chemistry. Okay, again, it's going into yeah. So basically, we touch upon production and chemical industries, manufacturing fertilizers, alkalis, acids, salts, dyes, polymers, drugs, soaps. It plays an important role in meeting human needs for food, health care, and other material aimed at improving life. Provide methods for isolation of life-saving drugs. Some of the drugs are cisplatin and Taxol, which are effective in cancer therapy. AZT, acidothymidine, is used for helping AIDS patients. Okay, production of, so it also in superconducting ceramics. So there are various industries that are established related to chemistry. Environmental degradation is also again through the research and findings. So you'd have heard about recently we banned plastic usage,
Yeah.
right? So understanding how the plastics are not biodegradable and how it is polluting the land and even impacting the ecology of the land because of so much of dump. Okay, so however big environmental problems continue to be matters of grave concern to the chemists. Management of greenhouse gases. Have you heard of greenhouse gases? Greenhouse
Yeah. Yeah.
phenomenon?
Carbon. Yeah.
Yeah, yeah. So basically, all this rises up, and how does it affect?
Global warming. The ozone layer gets
Ah,
depleted and
it goes
yeah.
up, and interacts with the ozone layer, and kind of forms kind of some holes in the ozone layers, and it weakens it, and so what happens? The sunlight that comes through that has more infrared and UV rays come, and thus the environment becomes more warmer
Yeah.
than it was originally designed for.
Mm.
Okay, so biochemical process, use of enzymes, production of chemicals, talented and creative chemists for accepting some such challenges. Okay, so basically the first is, again, we just looked at the importance of chemistry, nature of matter, uh, everything around us, book, pen, water, air, all living beings are composed of matter. And as a matter, we occupy space. Matter occupies space. So the states of matter, three states: solid, liquid, gas.
Yeah.
I'm sure you're already aware of this well. So it has now the differences, the different states of matter, definite volume and definite shape. Okay, so solid, definite volume, definite shape,
Yeah.
and liquids, definite volume, but they take the shape of the container.
Yeah.
Okay, so gas, and they have gases have neither definite volume nor definite shape. They completely occupy the space in which container in which they are placed. Okay, so the classification, we could see matter classified as mixtures and pure substances, and in mixtures, homogeneous mixtures and heterogeneous mixtures.
Yeah.
So homogeneous means basically it would be of same types, okay,
Right.
same states or same, similar compositions. So heterogeneous means it's totally like two very different.
Yeah.
In pure substances, elements and compounds. So compounds are formed from elements.
Yeah.
Right. Okay. So solid, heat, liquid, and liquid cool becomes solid, and liquid we apply heat, it becomes gas, and gas we cool, it becomes liquid. So basically, this is like a general process. Okay. So and then
Yeah.
we'll also see some of the exceptions. The examples. So in the classification of matter, yeah, I think we already looked at it. So homogeneous and heterogeneous. Particles of components of mixture are uniformly distributed throughout the bulk of the mixture, and its composition is uniform throughout.
Yeah.
Sugar solution and air are the examples of homogeneous mixtures. It's not uniform throughout, and sometimes different components are visible. Mixtures of salt and sugar, grains and pulses, along with some dirt. Heterogeneous mixtures. So you can think of many more examples of mixture which I come across in daily life. Okay. Pure substances. So they are fixed composition. Copper, silver, gold, water, glucose, pure substance. And further be classified into elements and compounds. Consists of only one type of atoms. Okay. Water molecule H2O, 2 hydrogen and 1 oxygen combines together to form H1. Carbon dioxide molecule is 1 carbon and 2 oxygen. Okay, kind of combines together. And so now is CO2 homogeneous or heterogeneous?
Heterogeneous.
Not really.
No? Oh.
The reason is, see, think of this way. You can see basically it is uniform throughout. The mixture and its composition is uniform throughout. That is homogeneous.
Okay.
Okay? Mixture and its composition is uniform throughout.
Yeah.
So it is uniform. Like if you mix salt and sugar, let's say, you cannot say that you have mixed it uniformly.
Yeah.
When you take in a box and then you kind of mix it, you will at different areas. I mean, if you kind of block it, I mean, split it into different parts, you will see that the level of salt is like different in each of the portions which you kind of made or imagined.
Yeah.
Okay, because it is not a uniform mixture, it is heterogeneous.
Yeah.
It doesn't totally blend and this thing. Okay, and that is where in the art of cooking, we always look for homogeneous, whether it's all mixed very well.
Yeah.
So basically, any part you take, it will have the same composition. Okay.
Yeah. Okay.
Yeah. So that is the part. So not like different. I think the reason you said hetero is because you see
It
two
has
different, 2 oxygen and 1 C, but then you will take like any composition, you will say the same composition. Okay. So yeah. So you got to kind of understand as uniform composition is homogeneous, and where the uniformity cannot be guaranteed or it could have a variation is heterogeneous. All the atoms of one type, however, the atoms of different elements are different in nature. Some elements such as sodium or copper contains atoms as their constituent particles, whereas in some others, constituent particles are molecules which are formed by 2 or more atoms. Hydrogen, nitrogen, oxygen gases consist of molecules in which 2 atoms combine to give their respective molecules. So atoms of different elements, H, O, N, Cu, Na. So you know all this. H is hydrogen, O for oxygen, N for
nitrogen,
Cu for
copper,
Na for
sodium.
cool. Okay. So now 2 or more atoms combined, okay, compound is obtained. Moreover, the constituents of a compound cannot be separated into simpler substances by physical methods. They can be separated by chemical methods. So you understand compound, right? A chemical reaction takes place. Okay. And so it can't be like we can't physically separate.
Yeah.
Okay. So in the second So we just kind of see, saw the classification of matter. Now we'll just touch upon this carbon atom. Carbon atom. It contains molecule of carbon dioxide, contains two oxygen atoms combined with one carbon atom. Thus, atoms of different elements are present in a compound in a fixed and definite ratio, and this ratio is characteristic of a particular compound. So, in a compound, the ratio is the key, like the characteristic. Okay, so that's a definite ratio.
Yeah.
Hydrogen and oxygen are gases, whereas a compound formed by their combination is a liquid. It's interesting to note that hydrogen burns with a pop sound and oxygen is a supporter of combustion, but water is used as a fire extinguisher.
Oh.
Okay, so physical and chemical properties of matter and their measurement. So, how do we classify, look at the properties of the matter and their measurements? So we categorize into physical properties and chemical properties. So physical properties is what we can physically observe. Color, odor, melting point, boiling point, density. What is density?
Mass by volume. Mass by volume.
Okay. Yeah.
Yeah.
Mass per volume, and also the units are also important. You got to be clear that the mass and the volume units are of the same.
Yeah.
Okay, we use the SI units. Okay, so mass per volume, right? So mass per unit volume. Like when you divide mass divided by volume, what you get is per unit volume. Okay,
Yeah.
and and that mass per unit volume is the density. Chemical properties: composition, combustibility, reactivity. Okay, reactivity with acids and bases. Okay, so the physical properties are measured by changing the identity or the composition of the substance, and in chemical properties we see how it reacts differently with acid or base. Okay, so that's how we determine its acidity and basicity, also its combustibility. So combustibility is at what temperature it changes its form and becomes combustible, right?
Yeah.
So chemists describe, interpret, and predict the behavior of substances on the basis of knowledge of the physical and chemical properties, which are determined by careful measurement and experimentation. So, which is like, what is the first, for example, the instruction they give when you realize that gases leak, there's a gas leak. What is the first warning?
Makes a sound.
Sorry?
Makes a sound.
No, sometimes you may not hear the sound, but you will like.
Yeah, you can smell it.
You'll smell it. So, what is the first precaution to be taken when we deal? When we find ourselves in such a situation?
Move away.
Okay. Have you heard of that? Do not operate any switches.
Yeah. Yeah.
Because why?
It would react with it and explode.
Yeah, like why? How the explosion begins? What's the connection between the electric switches and explosion? So the gas is highly combustible.
Okay.
Okay, very highly combustible. Very small spark will set it on fire. Okay.
Yeah.
So now when the gas is filled in the room, now the spark in that switch. Okay. And the switch always operates. When we switch on, there's a very small spark that happens to the, like in the wire, between that point, between the switch and the wire. Okay.
Yeah.
So at the start of the electric flow, there is a spark that comes, and yeah. and that will catch fire, and yeah, and that is what now everything around, I mean, since it's filled with gas, it catches fire, and then the explosion happens. Okay.
Yeah.
So in the following section, yeah, so basically just a quick recap. So look at the combustibility and acidity or basicity. So basically these are the chemical properties. Okay. And the physical properties are like the shape, volume, okay, and the identity, the composition of the substance. Okay. Chemical properties requires a chemical change to occur. That is the measurement or observation of chemical properties requires a chemical change to occur. Okay. So it is properties of matter like length, area, volume. So these are the quantitative figures, and it is denoted by unit. I use English system and the metric system in different parts of the world. But yeah, but for your purposes of your exam, I think you'd be working out everything in SI units, correct?
Okay. Yeah.
Yeah. So, are you clear on? I mean, have you gone through conversion to SI unit? I think some of the basic units you'll have to memorize that.
Yeah.
So length meter, mass is in kilogram, time in second, electric current in ampere, and temperature in Kelvin, and mole, amount of substance in moles, and luminous intensity as candela, CD. Okay, because in some of the problems, it may be in different units, and then they will expect us to first convert it into SI unit. Okay. So I would suggest that you plan some time to memorize this conversion formulas.
Yeah.
Okay. Maintaining the national standards of measurement. Okay. Including definition. I think here we look at yeah. So it is that so each modern country, including India, has a national meteorology institute, National Metrology Institute, and they've been responsibility has been given to the National Physical Laboratory in New Delhi. So we establishes experiments to realize the base units and derived units of measurement and maintains national standards of measurement. So basically these are very important in order to, so now when people, so there are various industries and various products people produce and sell, and right. So now as part of this governance, when that inspection, I mean, government also have inspection teams, right? So now in order for all to talk the same language, these standards, national standards of measurement are very important. Yeah, so it has 7 base units, and the 7 base units have been listed. So you can see that the physical quantity. Okay, so the combustibility nature comes in the luminous intensity. Okay, of different substances, it will be different, and amount of substance. So the same amount of sand or the same amount of sugar, right? Like, but now how do you differentiate? Yeah, but you will have a differentiation in terms of the moles.
Moles. Yeah.
Okay. SI system allows the use of prefixes to indicate the multiples or submultiples of a unit. Definitions of base units. When did you last go through this? Because these fundamentals are very important when you work out problems. We usually make very simple errors and mistakes and lose some marks.
We've never really, like, based on the classes I've been to, we've never really gone through the textbook, to be honest.
Okay. But do you have that experience of making mistakes in that units conversion?
I have, because if I don't read the question properly and then I do
Okay.
how they've given, so
Yeah. Sometimes, I will not read properly, or sometimes because of the time pressure or some stress, will also kind of miss
yeah.
out. Okay. So this is one of the frequently occurring mistake, in fact, when we work out.
Mm.
So defined by taking the fixed numerical value of the speed of light in vacuum c when expressed in unit meter per second. So ms power minus 1 is meter per second. That you know,
Yeah.
right?
Yeah.
Second is defined in terms of the cesium frequency, and kilogram. So just remember about the speed of light in vacuum is
3 point. Okay.
what is your 3 into, I think you will not remember this number, right? And also you may have they may allow, they may give the formulas and some values, correct?
Yeah, true. They would mention
In the
it in the
exam.
question. Yeah.
But as of now, just kind of understand it's 3 into 3 to the
10
power
to
of 10 power.
8.
Yeah. Okay. And then you know that it's some 299 something.
Yeah.
This number is 3 into 10 to the power of 8. 6, 8, yeah. And kilogram, Planck constant. Planck constant, I think that also be given, right?
Yeah. 6 point.
Okay. 6.62, into 10 to the power of minus 34. Fixed numerical value of the Planck constant to be when expressed in the unit. What is Js?
Joules second.
Okay. And joules second is equal to kilogram meter square per second.
Okay.
Okay, so joule is what? Work done.
Okay.
Correct?
Yeah.
Work done. Work done is expressed in terms of
Joule.
now, like, what is the work done formula? Do you recall?
I actually don't recall it.
Mass
Is it
into
force? Okay, mass into.
mass into
I thought it was force by
distance.
area. What is force by area?
Sorry?
Force by area is what again?
Sorry, say it again.
No, like you said, work done is mass into.
Distance.
Okay.
Correct? How much the distance it has traveled.
Okay.
Okay.
Yeah.
And when we now take into like at the velocity per unit, and that is where you see the kilograms for mass.
Yeah.
Okay. And then m stands for
Meter.
meter. Okay. Into distance. And then you can also see meter per second. What is meter per second?
Meter per second is acceleration.
So meter rate of change of distance, displacement. Okay, rate of change of displacement is velocity.
Yeah.
Correct?
Yeah.
And rate of change of velocity is
Acceleration.
Okay, how the velocity changes over time period per unit.
Yeah.
That is why the meter per second divided by again seconds. So you see the acceleration unit as meter per second square. Okay, fine. Basically, it's work done. Unit of time. Cesium frequency. Hyperfine transition frequency of cesium. unit hertz, which is equal to 1 second. Okay. So basically, like imagine this way: if someone asks like what is 1 second, I'll say this is 1 second, right? But now in order to have a standard unit which all will agree to, then there is a standard of measurement which they've done, and I mean with various, right? Because my clicking sound of my thumb or this thing is not a, I mean, depending on the size of the thumb and the pressure and all those things.
Yeah, it wouldn't be accurate.
Yeah, it'll have a like variation. Okay, so cesium frequency. Again, don't have to get into like I don't think I got to remember all those unperturbed ground state, all those things are not very important. But yeah, just think of it like cesium frequency, ampere defined by fixed numerical value of the elementary charge when expressed in the unit. So elementary charge value E. Okay, and Kelvin. Kelvin, like the Boltzmann constant K. Okay. So the number of units. Okay. So sometimes when we explain, let's say someone asks me on like what is the height of that wall. Okay, so I will say roughly 2 times of myself. Okay. Right. But yeah, but here, so in order to have uniform wear, so you kind of take a Boltzmann constant. The kilogram meter and second are defined in terms of Hc and delta V. What is the delta V? Cesium frequency. Delta V Cs. Okay. Second. Mole. So 1 mole contains exactly 6.022 into 10 to the power of 23 elementary entities. I think now they are sharing, right? So during my times, we used to just kind of memorize those 6.022 into 10 to the power of 23 elementary entities. Okay. So now it will now vary for different molecules. Correct? 1 mole contains those elementary entities. So now you can imagine how 1 mole of gold and 1 mole of sugar would have different number of elementary entities.
Okay.
Correct? I mean, are you able to visualize?
Yeah.
So this is Avogadro constant.
Okay. Yeah.
Avogadro constant. So any 1 mole of different elements, I mean, you got to take this many number of elements together as 1 mole. So an elementary may be elementary entity may be an atom, a molecule, an ion, an electron, or any other particle.
Yeah.
Candela, fixed numerical value. By the way, these units, do you have a sheet or do they give some reference, or are they expected to memorize these numbers?
I don't think we're expected to memorize these numbers, but Avogadro number, I think we have to know. And besides that, I think everything else will be mentioned.
Okay, fine. Luminous intensity in a given direction.
Yeah.
Defined by taking the fixed numerical value of luminous efficacy of monochromatic radiation of frequency. The kilogram meter and second are defined in, okay. I think. All right, I think so far we saw about the units. Yeah. The international system of units. And just, I think I would like you to memorize at least just this table, right? Like the amount of substance, molar, I think that you know, right? Luminous intensity, CD, thermodynamic temperature, K. Most of the problems, not most, like all the formulas will apply the temperature in Kelvin. That you know, right?
Yeah.
Ha.
Yeah.
So in some of the problems, you got to first convert it into Kelvin. Okay.
273.
Sorry?
You have to add 273 to the Celsius degree for it to be Kelvin.
Ha. Yeah. Okay. And from Fahrenheit to Celsius, do you remember those formulas?
Actually, they did give a formula for Fahrenheit to Celsius as well. I completely forgot that.
Okay. But do you know those measures?
Yeah.
No, like which 0 degrees Celsius is what Fahrenheit?
0 degrees Celsius would be 273 Kelvin.
No. With respect to Fahrenheit.
Oh, Fahrenheit. I have no idea about Fahrenheit.
Yeah. So just remember that. I think 0 degrees Celsius is 32 degrees Fahrenheit.
32, okay.
And 100 degrees Celsius is?
I have to add 32 to it.
212.
Yeah.
Okay.
Yeah.
And now with that, you can derive the formula.
Yeah.
Okay. It will go in a proportional way. In that proportional way is where that that equation comes.
Okay.
So anyway, when it comes, we will go into the details. Now we'll just touch up. We'll move on. Analytical balance. By the way, will it be expected to draw the analytical balance?
I don't think so.
Okay, so you don't
No.
describe
It's just multiple
balance
choices.
with the picture.
Okay. Yeah.
So anyways, yeah, just understand. I think you've been to shops, right? So in any balance, basically the platform at the down below. Okay, it is a leveling screw because you got to adjust so that it's a kind of a flat surface. Okay, so basically we try to establish like a neutral. It has to be that balance have to be. Without any weights, it has to balance. Okay.
Yeah.
But now when you put it up on a table, you will see, depending on the shape of the floor or the elevation of the floor, due to its imperfections, I will have to do a slightly leveling screw and all that. So how many leveling screw do you think this balance has?
I have no idea.
I just take a guess.
Okay.
Imagine this is sitting on a table.
Okay. Is it for the 4 or 6? No.
Okay, 4 or
Yeah,
6.
4.
Yeah. So the 6 would mean that there's a like in between they may provide 2 more.
Yeah.
Yeah. But typically 4 should be sufficient to kind of ensure a level surface. Okay, kind of adjust on the 4 sides and then. Okay, cool. And then there is a pan release. Pan release is to kind of set it to neutral. Then there is a beam release. What is this? The beam release would be with respect to, I think you may be able to raise it up and down.
Okay.
And then the pointer scale, the scale shows what is it. Okay.
Yeah.
So the beam is often the this particular part. Okay. So in order to like first it has to be fixed before you put the weights. Okay. And then there's a rider carrier knob. What is this rider carrier knob? What rides on this?
Do you have to does it help you to tighten it or lose it?
Yeah, so there's a beam here, right?
Yeah.
So this is the beam, this horizontal rod. Okay, rider carrier.
Yeah.
Okay, so this is to adjust this whole structure within the frame to the left or to the right.
Okay.
Okay. So the reason they are giving this is, now when you give, I mean, like on one side when you put some weights, and the other side you put some substances. Some substances will take bigger volume. Okay, so you slightly move that to the right.
Okay.
So anyway, yeah, just remember, there's a beam and there's a rider carrier and rider carrier knob. So basically to kind of fix it. And okay, and then the pan to rest the weights. And yeah, and then the span release, pointer and scale. Okay. Mass and weight. Okay, so mass of a substance is the amount of matter present in it, while weight is the force exerted by gravity on an object. Okay, this is a very important concept to remember. This is another place where there are like frequently occurring mistake.
Yeah.
Okay, force exerted by gravity on an object. Okay. So have you been in a giant wheel?
Yes.
So now when it goes up, like you will kind of experience that your weight, like you are pressed against the seat.
Yeah.
Okay. And when it comes down, you will experience that you are going to kind of float or kind of going to lift up, right? Like you'll feel light against your seat. Okay. So basically the force is operating there is gravitational force as usual, which is pulling up, but and also now the speed, like the centrifugal force of the giant wheel. So when it goes up, it that centrifugal force acts on you, and you in turn the body acts on the seat, so you kind of feel like kind of pressed. Okay. Yeah, so weight, I mean, why I'm kind of giving this example is it's a force exerted by gravity on an object. So by default, what is the weight of this phone? Mass into G, mg. Okay.
mg.
Mg, mass into gravity. So, and also in the chemistry, we mostly deal with mass. In physics, we mostly deal with, because we will be like dealing with the kinetics, like basically the movements. You will often see the weight taken into consideration. Okay, because both, like all the forces are also taken into account. So the mass of a substance is constant, whereas its weight may vary from one place to another due to change in gravity. Have you seen that astronomical the astronauts and the vehicles, the vehicles they use? So when you go up, let's say you're going to moon, and there the gravitation 0, and that is why it all kind of designed for those special purpose. Okay. And similarly, when it is accelerating and when it is traveling, okay, that is where in the cycle, like you can achieve some speed, whereas in the bike you can achieve a bit more, and in car you can achieve more than, right? Like because now the force that acts on the object differ. Okay, so it has to be of different structure, composition, and okay. You should be careful in using these terms. Mass of a determined accurately in the laboratory by using an analytical balance. And volume is amount of space occupied by, what is the unit of volume?
When? Cube, meter cube.
Meter cube. Okay. So yeah, so it's like the 3-dimensional height. I mean, it'll have a length, breadth, width. Right? All of it taken into the volume. So yeah, meter cube. Smaller volumes are used. 1 liter is 1000 milliliter, and 1000 centimeter cube is equal to 1. What is DM3?
Where is this? Deci, is it?
Yeah.
Yeah.
Okay. So yeah, so just you got to just memorize this. I think you may already know. I think, but if not, just remember 1 liter is 1,000 milliliter. By the way, as we are talking and discussing, are you also taking notes?
Yes, I am.
Okay. Yeah, because that's where like at a later talk, at a later point, like you can refer those notes and you can also recall the conversations. Okay.
Yeah.
So we are all kind of designed for reviewing to recall, and only then it stays in our memory. Okay. So first time we hear and we'll be confident and it goes into short-term memory.
Yeah.
But now, based on the number of times we recall that, it kind of stays in the long-term memory. Yeah. So okay, good. So take notes. So volume of liquids can be measured by graduated cylinder, burette, pipette, etc. What is the meaning of graduated?
Graduated, like gradually, like, okay, I don't know how to explain it.
Yeah, graduated means there is measurement of the units of measurement are marked on that.
Okay. Okay.
Okay.
Like in a thermometer.
Like if you look at this burette, now you'll see lines are drawn there and numbers are written on it. Okay, yeah, similar to the thermometer you're seeing. You'll see small lines like major lines, minor lines. Major lines you will see it in every 10 or like, in fact, it also depends on the size of the thermometer. Okay, so they are like more space to write, they will write some graduated cylinder. Just with the level of water, we'll just know like where it is. Okay. And volumetric flask will have a mark here. By the way, can you see my arrow movement?
I can.
Okay. So we'll have this movement and you just fill it like 1 liter when someone, I mean, you need to use 1 liter of something. You just use this volumetric flask and fill up to this level, right? So it's faster, quicker. You just like pour it and just like look at this. I mean, how far it has come. Yeah. So this is like measuring devices. 1 second. Okay. So yeah, I think I don't want to till what time shall we go? Yeah, I think we've been talking for an hour, like bit more than an hour. Shall we take a break for today?
Yeah, I mean, anything is fine with me.
Okay. So we'll take a break, okay?
Okay.
So tomorrow I'll ask you some questions on what we have covered so far.
Yeah, sure.
All right, then. Yeah, have a good day.
Thank you.
Bye.
Bye.
Bye.